We are back, people. What are we looking at today? Well, we're looking at fractional operations in more detail. What does that mean? Well, in the last video that we did, we actually looked at the basics of the operations: addition, subtraction, multiplication, and division, without necessarily going into too much practice in terms of what that looks like when we have actual questions. Today, we're picking up where we left off, and the idea is to get some practice, right? And we're going to do that by just, starting with some basic questions, right? I'm going to start with an example here: 2/3 plus 3/4, all right? And ideally, we want to add these two things. And we can't easily do that because the fractions don't have the same denominator. We spoke about why this is a difficulty, but we can just like kind of recap what that is. So the left fraction is divided into three parts, the right fraction into four. And if you look at any whole or unit, if you divide it into threes or thirds, those pieces are going to be larger than if you were to divide that same whole into fourths or quarters, right? And so what we're trying to do is to express both fractions as fractions over the same denominator, right? In such a and in so doing, ensure that the parts of that whole that we divided are the same size, and so that means that we can add the number of pieces that we have, the numerators, right? Now, in order to do that, we need to find a term that both 4 and 3 can divide. That we'll be touching on the concept of lowest common multiple, but for right now, what we're looking to do is just find a number that both 4 and 3 can divide. Now, 4 and 3 don't have anything in common immediately. 3 doesn't divide 4. So we can say, let's look at the multiples of 4 and see if any of those are divisible by 3. We can look at 4 times 2, which is 8. 3 doesn't divide that, but 4 times 3 definitely is divisible by both 4 and 3. And in the same way, 3 can divide 4 times 3, right? Now, in this instance, and in all instances, to be fair, if I've multiplied the denominator here, for example, by 4, and I then multiply the numerator by 4, you can just see right here from the relationship here, I could cancel the 4's back out to give me 2 over 3. So if I've multiplied the denominator by 4 and I've multiplied the numerator by 4 as well, I haven't changed the value of the fraction, right? I've created what is called an equivalent fraction. And that's really all equivalent fractions are. It's ensuring that if I were to have a fraction and I wanted to, for example, multiply the denominator by a term, that I also multiply the numerator by that term. Likewise, if I had a fraction and I divided the numerator by a term, I'd also have to divide the denominator by that same term to ensure that the fractions are the same. All right, now we're on the same page. I have 3 over 4 over here. If I look at the denominator, I've multiplied by 3. So the numerator must now be multiplied by 3 as well. And these are fractions, right? Now, having said that, what does that mean moving forward? Well, for us, and maybe I could just work it in this space, right? For us, what that means is that our denominator is 12, right? And we talk about a lowest common multiple. In this case, 12 happens to be the lowest common multiple, right? It is the multiple of either of the terms, that is the smallest multiple of either of the terms that's divisible by both of the terms. So there's no smaller term that could be divided by both 4 and 3, hence the lowest common multiple. Now, do you always have to find the LCM when working on fractions? The quick answer is no, right? We don't have to find the LCM. All the LCM does is it gives us fewer simplifications to our final answer, if there are any simplifications at all. And so I don't want you to stress too much about finding an LCM. If you can think of a common multiple, a term that both 4 and 3 divide, for your new denominator, for your equivalent fractions, you work with it, right? Efficiency and effectiveness will come with time in terms of you identifying an LCM. But it's just for you to know that it works regardless. Once your math is right, your answer will be right. So the numerator here, if I multiplied 4 by 3 on the right hand side, I got 12. 3 by 3 here gives me 9. Likewise, 3 by 4 gave me 12. And 2 by 4 will give me 8. And we're in good stead, right? So if I just draw the line right there, our next line in this fraction is going to, of course, have our denominator of 12. 8 and 8, 16 plus 1, 17. gives us our numerator. Now this is an improper fraction, right? Why is it improper, you say? Well, it's improper because our idea of a fraction is that it's a part of a whole, and as such is less than one, right? A half, a third. The numerator is smaller than the denominator, and so that's what we perceive to be a proper fraction, and what we know to be a proper fraction. In this case, the numerator is larger than the denominator, and so it's an improper fraction. Hopefully it makes sense. And ideally, we could envision that this is the same thing as 12 over 12 plus 5 over 12, or 1 and 5/12. Hence, our mixed number. I know I don't have enough space, but yet still I started it. Okay, such is life. And we're on the same page. Now, is it okay to leave your answer as 17 over 12? The answer is yes and no. Yes, the answer is correct. And no, the expectation is that when you're writing your fractions, you write them in the simplest possible form. And for improper fractions, that happens to be a mixed number. We're looking for that. You you get marked down by some teachers, by most teachers, to be honest. And so you want to always try, if you do get an improper fraction, to express it as a mixed number. Now, the way that I've done this, where I've said, okay, 12 over 12 plus 5 over 12 does give me 17 over 12, and I can say that this is 1 unit plus 5 over 12, 1 and 5/12, is not necessarily the way that you would do it in most cases, but I just wanted to show you that this is what is happening. In instances where the numerator is considerably larger, that's not what you do. So given that I have, shifting this a bit, given that I have a 17 over 12, as we just said, right? What you'd commonly see happen is that your teacher would say, how many times does 12 divide 17? You'd say 1, miss, sir. And then what's left? Well, the remainder there is 5 over 12. And that's how we do it. And it's more effective to do it this way because, of course, your numerator is not necessarily just slightly larger than your denominator. It might be several multiples larger. So it would be easier to take that approach. All right, so I'm hoping that you're comfortable with that idea. We kind of touched on equivalent fractions to an extent, and we also touched on mixed numbers and proper fractions. And of course, finding a common multiple in order to add, and that also works for subtraction. Now, what I want us to do is to look at some more interesting questions, because the question that we just looked at is super basic, right? So what we want to do is look at something that's a little bit more interesting, a little bit more complicated, that has several operations, and get an idea of how that works, right? Now, I know we're jumping from the frying pan into the fire, but you should be comfortable with these concepts as is right now. What we're trying to do is to get you a bit more comfortable. So let's kind of jump into something else. Let's see if we can get some other work done, right? So let's say I had a question. Let's go 3 and a half plus, let's go 2 and 3/7, right? Let's freestyle it, right? I want to do this kind of question because it starts with it starts with your mixed numbers, and I want you to understand that there are a couple of ways that we can approach this, and that you need to be comfortable either way. Apologies. Now, the first way that you're going to be more comfortable with or more familiar with is to convert these improper fractions into these mixed numbers into improper fractions, right? So you might start by saying, okay, what do I have here? Well, these are 3 units, and the base or denominator is 2. So I can say 2 times 3 to give me 6 plus 1 gives me 7 over 2, right? Plus 7 times 2, which is what? 14 plus 3, and we say that's 17 over 7. And then we can work on it, right? Now, I've just converted. I don't know if you're comfortable with the conversion, right? One way to look at this would be, if I was converting 3.5, I could consider this 3 units plus a half. But if each unit is with a base of 2, then I could look at this as 3 times 2 over 2 plus a half. 3 of these, right? Which should be 6 over 2. If I look at this as 3 over 1 plus a half, which is 7 over 2, right? This is a lot. So instead I could say, okay, I have 3 units. Each of them, right, is the unit size is 2. It takes 2 parts to make that unit. So I could say 2 times 3 is 6 in total of the the fractions that require 2 units to make a whole, plus 1 is 7. So 2 times 3 plus 1 is 7. Likewise, I could say 7 times 2, 14 plus 3, 17 over 7. And that's how we get that answer over there, right? I guess I'll leave that up for a bit so you can kind of take a look at that. Let me just partition that off. All right. All right. So let's get to this point. Now, what do we do here? Well, the process is going to be the same, right? It's going to be more of, I need the denominators to be the same. What's a common multiple that both 2 and 7 can divide? We can go 2 times 7 plus 7 times 2, right? Denominator here is 2, so we'll multiply it by 7. And then denominator here is 7, and we'll multiply by 2, right? So what do we have now? We're almost there. We have a denominator of 14 on both sides, of course, and we have 49 here, 7 sevens, and then 17 times 2 should be 34. And we're almost there. My 49 looks horrific. Don't judge. All right, we're on the same page. I know y'all can't write either. All right, as mean-spirited. I can live with that. All right, the denominator here is 14, right? And the numerator is 49 plus 34. Let's make it easier. Let's go 50 plus 34, which is 84 minus 1. We've got 83. I have no idea how many times 14 goes into 83. All right, let's presuppose 5, right? 5 times 14, I'm going to get 70. Cool. All right, so that should be, that should be 5 times, because 5 will give us 70. What's the remainder when I subtract 70 from 83? Should be 13 over 14. So 5 and 13 over 14 would be our answer here, right? Hopefully you're comfortable and understood the process. Going through this question, we did have a little bit of multiplication over here with a conversion. That's not necessary. We probably won't be using that methodology going forward, but hopefully you're comfortable with the idea and the process, right? All right. What's next? Let's try something that's on something that you probably see in an exam. Yeah, one of those more exam type questions, right? So here is one. The exams nowadays are a bit watered down, so you probably won't see one of these, but it's good to kind of practice the more interesting of the questions that you can get, right? And we're packing it up with all sorts of lovely operations here. Yeah. Heavy lifting, us who don't like fractions. You're going to have a problem today because it's all fractions. All right, so let's work, right? Now, cardinal rule. If I have mixed numbers here, can I divide them? Nope. Can't divide mixed numbers, not in the way that you presuppose. And I'm realizing now that I had a question that I'd meant to do 2 ways. This is that question. All right, let's do this. I'm going to table this question for a second, right? I'll get back to it. But this is what happens when you freestyle in this thing. I did want to do this question 2 ways. This one right here, right? So it's 3.5, 2 and 3/7. 3.5, 2 and 3/7. 3.5, 2 and 3/7. So let's put that down. 3.5 plus 2 and 3/7. Then we can just check and confirm. Am I right? That's what I just said. So you get older people, your memory goes. And this is the answer that we're going for here, right? I'd mentioned that there's another way to do this. This is the way I would want my students to do this question, right? Luckily, I remember this. I mentioned it and I was about to run away. All right, no, I don't necessarily want you doing all of this work with the mixed number. You don't need to, right? Here's the logic. All you really need to do here is I need for you to add the whole numbers. These are whole numbers. This is 3 over 1 and 2 over 1, so I can add them. So in essence, what I should have in the second line is 5 plus a half plus 3/7, right? These are smaller fractions to work with. This is beautiful. This is what we want. We want to work with small fractions. We don't want to do all of that extra stuff, right? Keep it simple, right? Now, if I'm adding these two again, we know the denominator. We know it's 2 over 2 times 7 and 7 times 2, right? Because both of those numbers, 2 and 7, divide 14, right? So 2 goes into this number and 7 goes into this number. All right, we're almost there. Let me do this on the other side so we don't have to go too far. I have everything in frame roughly. So I still have my 5 here sitting. It's sitting pretty. Doesn't have to be messed with. This is 7 over 14 plus what looks like 6 over 14. And we end up with 5. And what's is 7? 7 plus 6. 6 and 6 is 12. So this is, right? So this is 1, 2, 3, 4 steps. What did we get before? Right? I would expect, be dragging this all over the place. I would expect that if you're doing this kind of question, this is the approach that you're going to take. Work with the smaller fractions, add the whole numbers, make your life simple. And we can do that for addition and subtraction. Not possible, which is where my mind kind of jumped and went, oh, yeah, we're supposed to do this. That is not possible with our next question because we're going to multiply in this next question, right? Okay. All right. I have the question in front of me, so I will not forget it. So we have 4 and 4/5. We're packing it up. We did multiple operations in this question. All right. And I think I can probably do one more question after this one. Plus, you probably a bit tired yourself, right? Let's knock this out. So if I'm doing this question, my first order of business is to work out what is in my brackets before I even touch the subtraction. I can't subtract what I don't know, right? I need to know what this is and this is. This is one large term I need to calculate. This is another large term I need to calculate. So I'm not doing this till last, that subtraction operation. Let's get to it. Now, in order for me to divide, I first have to convert the mixed number to an improper fraction. So we're going to say 5 times 4, which is 20, and 4. 5 times 4, 20, plus 4, 24 over 5, divided by 3 times 2, 6 and 2, which is 8. I love it. You're doing well. I can't square this till I know what this is, right? So 3 times 1, 3 and 1, 4. So again, here I said 5 times 4, 20 plus 4, 24 over 5. 3 times 2, 6 plus 2, 8 over 3. And here we said 3 times 1, 3 plus 1, 4 over 3. Now we can work. We're getting into it now. We're digging in. All right. I like it. Fractionally, I cannot divide these fractions, right? There's the operation itself is actually a division by any term is actually a multiplication by its inverse, right? So goes for whole numbers as well. It's a multiplication by the inverse. So here, when I divide by 8 over 3, it's the same as multiplying by 3 over 8. We're on the same page. I'm going to square this. And if I square a fraction, that means I'm squaring the numerator and I'm squaring the denominator. Those are twos, people. Remember, don't judge. We're not judgy people in 2026. We probably are and we're lying, but that's fine. Now for multiplication, I can multiply straight across. It's always numerator times numerator and denominator times denominator. However, we can make it a simpler multiplication if I can divide, because let me show you the rationale behind the cancellation process, right? We normally just go 8 into 8, 1, 8 into 24, right? 3. But it's really, we can really only do that because this is one fraction when we're multiplying. And so I can divide that single fraction numerator wise by 8 to give me 1. Sorry, denominator wise by 8 to give me 1, and numerator wise by 8 to give me 3, right? And in the same way that you could actually, for me, it's easier to visualize this way. I could call this a multiplication by 8 over 8 and then do the cancellation as well. But I think this visually makes more sense, right? And then I end up with 4 squared, which is 16 over 9. That is a 9. And you will accept it. All right. This becomes 3 threes. 3 threes, 9 over what looks like 5 minus what looks like 16 over 9. We're almost there, people. So it's a good question, right? This is equal to, again, in order for us to add and or subtract, we're going to need to have the same denominator. We can't do that as it is because we have 5 and 9. I'm not going to worry about finding an LCM. I'm just going to find a common multiple here, which makes sense. Here I have 5 multiplied by 9, so I must multiply the numerator by 9 as well. Here I have 9 multiplied by 5, so I must multiply the numerator by 5. Almost there. Boy, I have a knack for not selecting the pen. All right, so we end up with 81 over what looks like 45 minus what looks like 80 over 45. And you should be comfortable with the calculations. If you're not so sure what was done there and you're not comfortable multiplying 16 by 5 or 5 by 16, multiply 5 by 10, right? 5 tens, and then multiply 6 by 5 because 16 is 10 plus 6, right? And here what I will end up giving us is 5 times 10, 50, and 5 times 6, 30. And we'll add them. We get our 80, right? So we're good. So not as horrific as it might look. And we know, of course, that the denominators are the same. So all I have to do now is subtract the numerators, and we end up with our numerator of 1. All right, good stuff. What I love about these compound fractional questions is that you get to do a little bit of everything in them, all right? We're going to do one more, and that's it, yeah? All right, that's the last of it. You're doing well. We'll find one more that looks a little bit different. Let's try this one. All right, let's try this one. Good stuff. I am tempted to do a couple more of these, but we'll see. We'll see how that goes, right? So we'll start with 5 1/4 minus 2 1/3. I like it. Divided by 2 1/2. I like that too. All right. We're dividing, and we'll talk about order of operations, and your teachers will belabor that, and that's cool. But common sense should tell you, and I'm going to say that, hopefully it's not disrespectful and or derogatory. I want to divide something by something. I have to know what that something is. What is this thing I'm dividing by 2 1/2? In order to do a division, I need to know what this is first. So let's do that first, right? It's basically you understanding what you need to do, and in order to do that, what you need to calculate, right? So I need to work on my numerator. Let's do what we did before, right? And I'm going to be very careful with how we write this. This is something minus something else. So this is 5 minus 2, right? 5 minus 2 plus 1/4 minus 1/3. I'm hoping that you're comfortable with that, right? Ideally, this is 5 1/4 and 2 1/3. But these terms are subtracting these terms, right? So I can subtract the whole numbers, and then I can subtract the fractional part. And that's what I've done here, right? Divided by our mixed number here, which I'm going to convert. 2 times 2 happens to be what? 4 plus 1. Oh, you need to select your pencil. That's what happens when you don't select your pencil, right? So we'll end up with that, right? Now I'm going to just separate here, and I'm going to write this as 3 1/4 minus 1/3, all divided by 5 over 2. I'm not messing with that till near the end, right? So this is going to be 3 plus a term over 4 times 3 plus another term over 4 times 3. And I want in about the space, but we'll make it work. Can we? I might have to do this in another line. Let me see if I do this down here. So we had 3, and what was it now? 3 plus a quarter minus a third. Divided by 5 over 2. All right, we're good to go. If only I would write these things properly, we'd be even better. All right, so we end up with 3 here, plus something over 4 times 3 minus something over 3 times 4 divided by 5 over 2, right? I've multiplied the denominator here by 3, so I'm multiplying the numerator by 3. I've multiplied the denominator here by 4, so I'm multiplying the numerator by 4. We're almost there, people. Yeah, we end up with 3 plus what looks like 3 over 12 minus 4 over 12 divided by 5 over 2. We end up with 3 minus 3 over 1 minus 1 over 12. And again, we need common denominators here. So if the common denominator is 12, then 1 times 12 gave me 12. 3 times 12 will give me 36. That's a 3, I promise. All right, we're finishing up. I knew that was going to happen. All right, so 36 minus 1, 35 over 12 divided by 5 over 2. And we're almost done. This is almost a war of attrition, right? 35 over 12 times 2 over 5, because whenever you divide by a fraction, it's the same as multiplying by its inverse. Long and short of it, now we have 35 times 2 over 12 times 5. I can divide this term in the denominator by 5. I can divide this term in the numerator by 5. Doesn't change the value of the fraction, because again, remember, if we did the same thing to the numerator and denominator, we have is a equivalent fraction, right? Divide this numerator by 2, divide this denominator by 2, and essentially we end up with 7 over 6. And we don't leave it there. We can say or 6 divided 7 to give me 1 with a remainder of 1 over 6. Gentle people, I've had you here for nearly half an hour. I want to do more of these. I probably will create another video going through more exam type questions. I want you comfortable with fractions because it's the base of all of these calculations. There are games and practice quizzes on the website. I don't know if I'll do a worksheet for you to print, but we'll see how that works. Ideally, it's all about practice. The more we practice, the more comfortable you become. Thanks for sticking and staying. Like and subscribe. Don't forget to do that. And I'll see you in the next one.